having had a look at unknown sample A already, where I went more in depth into that answer, I'm going to go a bit more quickly here through unknown sample E. Again, going through the tests as they are given to us. First, we're starting off with an unsaturation test, and we're showing that the orange color remains. So what I'd be writing down is that there are no color change with bromine. Obviously, it helps if I can spell and or type. So no alkene or alkyne. That's really what I'm getting out from that. There's no double or triple bonds, as the bromine didn't react with those in the system. I can see from my oxidation test that when I actually try and oxidize the system, the solution turns green, so a change has occurred. So that would imply that there is something that can be oxidized. So oxidizable group in molecule. And out of the ones that we have seen, the most likely oxidizable group is an alcohol. Again, spelling is going well. Yes, I thought that one had a Z and I refused because I'm Australian. So we know that there's something oxidizable in there, possibly an alcohol. I should change that language ever so slightly, but that's the most likely functional group from the ones that you have encountered within the HSC. Last but not least, we're told that we have our carboxylic acid test. There are no bubbles as a result of that test. And so we would say there is no carboxylic acid present. That one's nice and easy. It either shows it's there or it shows it's not. Moving on to our IR. At this stage, I'm already suspicious that I probably have an alcohol. And if I ignore anything under 1500, the fingerprint region, the only things left of interest really are a signal here and one here. And so I've got this really strong, broad signal at about 3300. And that is typically associated with an alcohol. So again, very likely to be, I'll still say possibly, just in case, but I've now got two hints that I've probably got an alcohol in there. The signal at about, so I'm getting a bit sharper there, so the strong, sharp signal at around about 2900. That's just your CH stretches or CHs in the system. Most organic molecules are going to have that. So it's not really telling us anything interesting. But again, we've got that potential confirmation of my alcohol. Moving into the mass spectrum, what I can see, we're already told the molecular ion is 32, but I can read that off and confirm that my molecular ion is indeed about a mass to charge ratio of 32. I don't tend to look at fragmentations. You can spend a lot of time there, but there are some very common ones present. So this one at 15, very common fragment for coming up at 15 is a methyl group. And the distance between that methyl group and our parent ion is a mass to charge ratio of 17, which is very common. Again, if I see that number, I start to get suspicious that I potentially have an alcohol. So oxygen and hydrogen together have a mass to charge ratio of 17. And so just with those two fragments, I can make up the entirety of that mass that I'm interested in. That's also particularly interesting because we already thought I probably have an alcohol. So what I would say that I'd actually write down and say an exam or a quiz, mass to charge, molecular ion of 32. I would say that I probably have a methyl fragment at 15 mass to charge ratio, and the rest of the fragment or molecule at 17 is likely an OH. So I'm building up this idea. I would even say at this point that the molecule is perhaps methanol, which is just that methyl group with an OH. So I haven't confirmed that yet, but I'm pretty suspicious that this one's pretty simple and that I'm just looking at methanol as my molecule. Let's go on and see if I can confirm that with the rest of my data. Going into my 13 carbon spectrum here, I can see that I have one signal at about 50 ppm. Firstly, if I only have one signal, it means that I only have one carbon environment. It's possible with symmetry, I might have more carbons, but I can just say that I've got one environment overall. With a chemical shift of about 50, I'm saying that, well, it's near something electronegative. So for my notes here, I'd say one carbon environment at 50 ppm, therefore near electronegative element, e.g. O and nitrogen or oxygen. Again, thinking back, well, that makes sense. Our methanol only has one carbon in it, and it is, of course, bound directly to an oxygen. So this carbon NMR makes a lot of sense. Going to my proton NMR, I have two signals. One a little bit easier to see than the other. So there's this big singlet here, and this small, slightly broader singlet just after 4. So again, let's write this down. I have a singlet at 3.5 ppm. Oh, that's nice and bold and exciting. So we know we have our singlet, therefore no neighbors. And I can read down a little bit further on the page, and I can see that I've been given the peak data, and particularly the peak area ratio, otherwise known as the integration. And I can see that if my small signal here has a peak area ratio of 1, my much bigger one, my big singlet, has a ratio of 3. So they're in a ratio of 1 to 3. Typically, when I see 3 protons in one environment as a singlet, this is likely to be a CH3 or a methyl group, where it has no neighbors that it's coupling to. We have a slightly broader singlet. Again, helps if I can spell. At about 4.4 or so, 4.3, just a rough guess. So we can say, well, if it's at 4.4, both of these are close to something electronegative like before, because they are up high above 3. And this broad singlet is very characteristic of an OH. Note that for alcohols, that hydrogen does not undergo splitting. So you're not going to get doublets or triplets. It will stay as a singlet. And that broad nature is very characteristic of something like an alcohol. And as I said, those signals, in this case, in this sort of 3 to 4.5 region, therefore near something electronegative again. So I can just grab this from above. I'm going to cheat and just copy and paste it. But again, I would say I'm near something electronegative. Putting this all together, there's only one molecule that holds to all of this. We have our likely methyl group. We have our alcohol. We've already said earlier on that the only thing that makes sense is our methanol. We know that that is the only structure that's going to hold to all of this. So thankfully, this was a little bit easier of an example, but not always this clear cut. And to be honest, I had the answer on the first page, but that's all the data written out for how I would justify sample E being methanol.